So this is the theory for designing a slab supported by walls and a slab supported by beams. We designed a slab supported by walls to counteract shear and bending. Slab supported by walls. However, the slab supported by beams is designed to counteract shear, bending, as well as torsion. So slabs supported by beams, they are designed to counteract shear, bending, and torsion. The reasons is since it is cast as part of the beams, there is a tendency for the slab to twist at the intersection. To counteract the torsion, we can provide reinforcement as shown at the intersection of the beams and slabs on page 51 in my blue book. So it's either we put in these extra bars to counteract torsion, but usually at the intersections where we have intersections where they basically intersect with the beams. So we put in those two bars, and that's just to counteract torsion. But there's another way. We'll discuss it later on. And the other way is stated in this section. However, to make the reinforcement design easier, we can also lap a bar shapecoat 38 directly onto every second main steel. This bar, that is shapecoat 38, will serve a dual purpose. It will counteract the tendency for the twist at the beam slab intersection and simultaneously reduce the amount of reinforcement required to 50% as the bending moment tends to zero, moving towards the supports. So that's basically the theory for that one. And then for the sketch of this section here, the second section of how you can actually implement your steel, is shown in this figure, in this drawing. So you usually have your main bars, and then your main bar is connected to your shapecoat 38s, straight bar connected to shapecoat 38s, and then you have these dotted lines which represents the 3 bars keeping the shapecoat 38 in position. 1, 2, 3, 1, 2, 3 at the top. That's just to fix your U bars to your main steel in the bottom, in the tension part of your slab. So that's your second way of actually implementing your steel. You counteract torsion here at the corners using shapecoat 38s, the U bars, using those bars. Now this is for a slab supported on beams, and then for slab supported on walls, we will actually use the following method of applying steel. We will use this method where you have your main steel alternating, and then you have 50% of the steel in this area and that area. The same here, your main steel alternating, and you have 50% of the steel in those areas, because that's usually that you should take into consideration whenever the bending moment tends to zero. And that's how you actually design slabs supported by walls. So we did a discussion now on slabs supported by walls and slabs supported by beams. Now you just need to go and do your calculations on it, because that's the theory for it.